There are three fundamental principles to understand IPFS. Unique identification through content addressing, content linking through directed acyclic graphs, DAGs, and content discovery through distributed hash tables, DHTs. These three principles build upon each other to form the IPFS ecosystem. And we will start with content addressing and unique identification of content. Content addressing. IPFS uses content addressing to identify and locate content through what is in the content, not by where it is the content. For example, when you're looking for a person in an apartment building, imagine that, you often ask by the person's name, like, hey, I'm looking for Alice L. Do you know which room she lives? She's 25 years old with brown hair. That's content addressing. But if you were using the location addressing to find that person, you would ask by where she or he lives with the location information, such as, hi, I'm looking for that person who lives in room 203, apartment building 10. The problem with location addressing is pretty obvious. So if the person you feel looking for moved out or not home at that moment, you won't be able to find that person. When you knock the door, you will see a strange face or no response. The problem exists for the internet and on your computer right now, such as this Wikipedia link and this link on your computer, and also when you search some PPT on your computer as well. By contrast, every piece of informational content that uses IPFS protocol has a content identifier, or CID, that is hash. Imagine all the content like people with unique ID numbers. The hash is the ID number and unique to the content that it came from, even though it may look short compared to the original content. There are many distributed systems use content addressing through hash as a way for not just identifying content, but also linking it together. Everything from the commits that back your code to the blockchains that run cryptocurrencies leverage this strategy. Directed acyclic graphs, DAGs, like in many other distributed systems, IPFS also uses a data structure called a directed acyclic graphs, or specifically the Merkle DAGs, which are DAGs where each node has a unique identifier that is a hash of the node's content. Put another way, identifying a data object like a Merkle DAG by the value of its hash is content addressing. IPFS lets you give CIDs to the content and link the content together in a Merkle DAG. DHT, distributed hash tables. A distributed hash table is a decentralized storage system that provides lookup and storage schemes similar to a hash table, storing key value pairs. Each node in a DHT is responsible for keys along with the mapped values. Any node can efficiently retrieve that value associated with a given key, just like a hash table. Values mapped against the keys in a DHT can be any arbitrary form of data. DHTs have three properties: decentralized and autonomous. Nodes collectively from the system without any central authority. Fault tolerant. System is reliable with lots of nodes joining, leaving, and failing at all the times. Scalable. System should function efficiently with even thousands or millions of nodes.